If we are, for instance, a progression like 2, 4, 8, 16, 32, and 64. So the difference between these terms is not common, meaning these terms, let me just, someone wants to join the meeting. Let me just admit someone in the meeting. Yes, good evening, Madam Bianca. Welcome. We are just starting, we haven't done much. So we are looking on GP. So we are saying in a GP, when we have a progression which is a geometric in nature, where we have 2, 4, 2, 4, 8, 16, 32, and as well as 64. We are saying that in this progression, the difference in numbers is not the same. So since it's not the same, we are calling this difference as the ratio. We are calling this difference as the ratio, denoted by letter R. So it is denoted by letter R. So we are saying that if we are to find the ratio in this arithmetic, in this progression, geometric progression, we are going to say we pick 4. Let's say we want to find the ratio. So in the ratio, we are going to pick the preceding number. So let's say 4 divide by 2 is equal to, what is 4 divided by 2? We are getting a 2. So we will say the ratio is equal to 2. So in other terms, we are saying that the ratios vary in terms of 2 to 1 or 3 to 2, which is the T2. So we are saying that in ratios, we are actually dividing the term with the preceding term for us to be able to get the ratio, which is called the R. So we are saying that in a GP, when we total these ratios, they are able to equal to what you are saying, a common R. So let's say, for example, we are saying, for example, we have terms like 12, -4, and we have a term as 1/3. So this is a mixed fraction. So now we are told to say, we need to state the common ratio in this geometric progression. So I said find the common ratio. So if you are to tell that this progression is arithmetic or geometric, it is the way these numbers they tend to move. In a geometric progressions, numbers do not move in an even. So you will see that there is a 12, -4, and there is 1/3. So you can see that this number, the progression is following a geometric sequence. So if we're told to find now the common ratio denoted by letter R, we are going to say that -4 divided by Negative 4 divide by 12. Then our answer is equal to negative 1 over 3. So this now becomes our common ratio. So another example, given that we have a sequence like 1 over 2, comma 1 over 3, comma then we have 2 over 9. Then we are told to say find also the common ratio in this geometric progression. So for us to find the common ratio, we are saying common ratio is denoted by letter small letter r, which is equal to 1 over 3 divide by 1 over 2. So then we are going to say 1 over 3 divided by 1 over 2. So we are going to say is equal to 1 over 3. So when it is a divide by, in arithmetic we normally change this becomes our multiplication. So when we change this sign to multiplication, we swap the two numbers. So the 2 comes on top on the fraction, the 1 gets down. So then we are saying 1 over 3 multiplied by 1 over 2. So we are getting 2 over 3 as our common ratio. So if for instance again we have a geometric progression which is following a sequence which has got mixed fractions like 10 over 3 and 16, then 24. So we'll say if we are to find the common ratio, we are going to say 16 divided by 10 2 over 3. So we'll say here we can even put we can say over, just over 1, because 16 over 1 is still 16. Are we okay? Then we'll say therefore 16, we'll say 16 over 1 divide by, so we'll say this one to take it into a standard fraction. We'll say, I don't know if you're able to see my pointer. So we'll say 3 multiplied by 10 plus 2. So we'll say 3 multiplied by 10, that will give us a 30. Then 30 plus 2, it will give us 32. So we'll say 32 over 3. Then by the rule of division, we are saying 16 over 1, we change this into multiplication. So meaning by rule of division, we swap this, we interchange this, it will be 3 over 32. Then we multiply. Then so when we multiply 16 multiplied by 3, we are getting a 48. So you can also get your calculator so that we can be able to move together. So then we are saying 1 multiplied by 32, we are getting a 32. Then 43 divided by 32, we are getting 3/2. So this can be simplified further into an answer which is 3/2. So that now becomes our common ratio. Then let's now look on something. I don't know if the people are still copying. Let's now look on something more involving. So let's say we are taught to say the 12th term. This is coming from an exam paper. Let me just write it. The 12th term, it's like, just let me do this. Open a new board. The other one is skipping. Okay, yeah, okay, thank you. So we are saying that the 12th term, of a GP of the GP is 128, 64, 32, and so on and so on. Then you are tend to say we are told to say find the 12th term. Find the 12th term. So we are finding the 12th term for this GP. That is our A. Then our B, we are taught to say a formula for the nth term. A formula for the nth term. Okay, so let's get to it. So last time I gave you some formulas for normally for calculating the term of a GP, and we are saying that the formula for the term of a GP is Tn is equal to A R then n minus 1. So the n minus 1 in this formula is called the index. So this n minus 1 is called the index. The index of the formula. So now in our geometric progression, we have above, which is 128, 64, and 32. We have an A. So and we also have the proceeding number. So we say data in this will be, correct our data. So we'll say data, our A is equal to 128. So then what is our R? So we need now to find our common ratio. So our common ratio therefore will be 64 divided by 128. So we'll say 64 divided by 128. So when you divide this, we are saying our common ratio R is equal to 64 divided by 128. You can get your calculator and divide alongside with me. Then your answer is 0.5. So 0.5 now is our common ratio. So now we are told that we should look for the 12th term. So you're saying what you are looking for is T12. That is what we are to look for. Then from our formula, we are told to say Tn is equal to AR, then the index, which is n minus 1. Then at this point, we are now going to substitute our data in the formula. So we'll say therefore T12, which is the 12th term we are looking for, then our A, which is the first term in this geometric progression, is 128. Then multiplied by our common ratio is 0.5. Then our nth term, we are saying it is 12, which is the index minus 1. Then we are therefore saying that the 12th term is equal to 128 then 0.5. Then we say 12 minus 1, that is an 11 to the power 11. So then you can get your calculator and compute these figures the way they are. So you say 128 open bracket 0.5 close bracket. Then on your calculator, depending if the calculator you are using, if it is a sharp or if it is a casual. If it is a casual, on a casual, there is a sign which looks like this. So this is telling you to the power that number. So you say to the power 11. If you are using a sharp has got a function which looks like this. So you just say this to the power 11. So when you compute those, you have your final answer, which is to the power 11. What are we getting? What are we getting? So our T12, therefore, we are saying T12 is equal to 1 over 16. Are we okay up to this point? Let me get some reactions. Are we okay? Okay, so we move.
Sorry, is
Yes,
it
please.
giving a?
What are
It's supposed to give a fraction when you enter the figures.
okay?
I'm getting 0 point.
Yes. So if you get a 0.00 something on the calculator, once you get that answer, when you press where, if you are using a sharp, there is a symbol which looks like this, this. Then if you are using a casual, you press only the same where there is that where you are doing to the where there is that symbol fraction. When you press it, it will take your answer into fractions. So in decimal, our answer
Oh,
was 0.0625. So I'm using fractions for the accuracy purposes. When I begin to use decimals, the moment I begin to round off, I'll be moving away from the original answer. Is that okay?
okay. So I've seen.
Okay.
Yes, I've seen it. The 1/16.
Okay, thank you so much. So we are also taught in the question that we should find a formula for the nth term. So for us to be able to find the formula for the nth term now, we first write our formula, which is t, okay, so which is t n, which is the nth term, is equal to ar, a which is the first term, then the r which is the common ratio to the power index, and the index is we are saying n minus 1. So we are told to find a formula for the nth term, meaning the term in this instance we are not given. So we'll take the term as the n the way it is. So our a we know is 128. Then our R we have already found, which was 1 over 2, which was 1 over 2. Then we are saying the index, which is n minus 1, we don't know. We are now driving the formula. We are now driving the formula we are taught to formulate. So from here, we are going to say equals. We're going to say equals. So we are going to introduce indices in this equation. So for us to introduce indices, we are going to say the index of 128. So we are saying 128, the index of 128 is 11. Or we can say 128 multiplied by 1 over 2 n minus 1. So now we are saying here we are going now to say equals 128. We are saying the index of 128 is 2 to the power 7. So what we're trying to do, we want to have common base. So then this one is also can be written as 2 n minus 1 over 1. Then we simplify further. So when we simplify further, we are now going to say we are going to go by the rule of indices. So the rule of indices is that if we have common bases, we actually, if we have common bases, we actually subtract the power if there is a multiplication in between. So this also can be written, because we have common bases, this can be written as 2, this is the common base. Then we are saying 2 over 2 to the power 7 n minus 1. So this is just an index. some of the rules of the indices. So equals, I know when we do much of this they will make sense, but since we're beginning they might look a little bit confusing, but they will make sense as we progress. Are we okay? So since we are now trying to generate the formula. So since if we have a denominator which is common as the base, we can now again rewrite it as 2, 7. When we bring up the power on top, it becomes a negative power. So we are saying n minus 1 to the power n minus 1, which is the index. So then therefore this will become equals 2, 7 minus, so n multiplied by n, it will be negative n. Then this multiplied by that, it will be a positive 1. Then we'll say equals 2, 7 plus 1 minus n. Then we'll say equals 2, 7 plus 1, that is 8 minus n. Then this becomes our Tn formula. So the catchy part when we are dealing with questions which involve indices is here. Here is where our catchy part comes in. So for us to be able to solve these questions, we need to have a common base. So when you see here, let me put a pointer. So when you see here, we have a base to the power which is 2. Here there is a base of 2. So our key point is that we need to have a common base because we are dealing with now indices. These are indices. So for us to be able to have a common base, we say 2. What is the power which will give us 28? So we say 2 is a common base. We bring a 2 here. Then we look for a power which will give us 28. So 2 to the power 7 is equal to 128. So from here then we have common bases. So from the rule of indices is that when you have 1 over 2, when you multiply this is the same as 2 to the power 7 multiplied by 1 over 2. So this one is over everything. This one is over everything. So it's 2 to the power 7 multiplied by 1, which is this 7 over 2 to the power 7. Then this comes on the bottom of the equation. Then the rule of the indices is that when you have a base which is common to the denominator, we can say 2. If to move this power here, to take it on top, it will become, this power can become a negative power. So once a power crosses from the bottom of the fraction to the top part of the fraction, this power becomes a negative power. So hence this is now the negative you are seeing here. So then here we just multiply everything with the equation. Then you are able to get now to your final answer. So here we just now rearrange. Then we say 7 plus 1, which is 8. Then we have our formula, which is the nth term formula. So let's look on also something more involving.